But we've got a talk now from Adrian, so I'd like to welcome Adrian Winckles to come and chat to us. Adrian's a senior lecturer and senior researcher at the Anglican Ruskin University. Number of research projects in different areas, software-defined networking and other things to do with that, and many other areas around forensics and other things. But Adrian's here to talk about secure applications and I guess a little bit more under the OWASP banner and some of the involvement he has with that. So I'll hand over to Adrian.
Okay, thank you very much. Afternoon, everyone. As I was just introduced, my name's Adrian Winckles, and I'm talking today about no breaches here, I've got a firewall. Really, the need for secure coding. So I don't want to spend too much time preambling about myself, perhaps in the fact I probably wear too many hats. In my day job, as was introduced, I'm an academic, but I also lead the OWASP Cambridge chapter. I'm a OWASP Europe board member. For my sins, I've also picked up, at least temporarily, chair for the Cambridge cluster of the UK Cybersecurity Forum, and I do some work with the BCS as vice chair of their cybercrime forensics SIG. And there are too many things in my research portfolio to spend too much time on now. What I really want to talk about today was some of the continuing problems we have. There's the old adages or corny catchphrases. There are two types of organisation, those that have been hacked and those that still don't know they've been hacked. That still continues to ring true. Lots of industries, lots of firms have spent a lot of money putting in layers and layers of infrastructure defence in depth if you like, and they still suffer breaches, they still lose data. We keep saying that those on the dark side only have to be lucky once. We as defenders of our information have to be lucky all the time. But what is it that we've forgotten? What should we be doing to redress some of the balance? What should we be doing to increase our luck? Especially in the age of everything connected to everything else. So, if we've got all this infrastructure, I've got my firewall, I'm safe. Is that strictly true? Well, I've also got intrusion detection, intrusion prevention, endpoint protection. I've got my SIAM systems. I've got my VPNs, my antivirus. I've got back-end encryption. I stick SSL on everything. I've got an appliance for everything. But still they get in. And I was missing a nice slide that showed Swiss cheese. I like to think about infrastructure security, about layers of Swiss cheese. Everything has holes in it, but you cover enough of the holes and you've probably got a defence. But have you? Another point was, some people say, well, it's 0 days. Oh, it's all about if we can patch for a 0 day. Well, you can't patch for a 0 day because you don't know about it. The National Security Agency was saying there's no need to blame 0 days. There's enough targets to provide the attackers with a wide enough vector through poor cyber hygiene. That's another view. So, what problems do we have? To my mind, it's not just about infrastructure layers. It's not just about protecting the operating system. It's not just about what's known. If you know about something, you can write a signature for it, you can find it. It's not just about what's not known. So it's not just about 0 days. Some of it is about how we use what we've got, how we improve the security on the things we use and the processes and the procedures we have. But there's still a larger problem, one that I don't think we've really got to grips with yet. Some people have. So what's left? I'm hypothesising it's the application. The applications are where we're seeing most of the problems. Don't just take my word for it. Gartner have issued some statements in recent years. 75% of security breaches happen at the application. They also said again, over 70% of security vulnerabilities exist at the application layer, not the network layer. And they go on to say, if only 50% of software vulnerabilities were removed prior to production, costs could be reduced by 75%. It's not me saying this, it's Gartner. National Institute of Science and Technology in the US, 92% of reported vulnerabilities are in the applications, not in networks. We'll come back to that figure in a minute. And supporting what Gartner was saying, the cost of fixing a bug in the field is, say, in their words, $30,000 versus $5,000 during coding. There's a severe financial argument for getting security into the development process very early on. So just how many vulnerabilities are actually application related? If you use NIST data, they're actually saying that they think 92% of reported vulnerabilities are in the applications. I did a quick add up. That actually consisted of 41% in the server application, 36% in a non-server application, and NIST figures are actually bundling the operating system in there as well. So, if we made an analogy, if cars were built like applications, 70% of cars would be built without the following designs and blueprints. The other 30% would not have designs. A car would have no airbags, mirrors, seat belts, doors, roll bars, side impact belts or locks, because nobody asked for them. But at least you'd have 6 cup holders. Not all of the components will be bolted together securely. It probably might have wheels. Many of them would not be built to tolerate even the slightest abuse, so anyone with a screwdriver and it would fall apart. Safety tests would assume frontal impact only. Nothing about roll testing or stability in emergency manoeuvres, brake effectiveness, side impact or resistance to theft. Many safety features originally included might be removed before the car was completed because they might adversely affect performance. And here's the big one. 70% of all cars will be subject to monthly recalls to add major components left out in the initial production. The other 30% wouldn't be recalled because no one would sue anyway. So what I'm touting is that applications are the big issue. The vulnerability in the software, this could be at multiple levels. It could be at the sensor level, mobile application, hub, the cloud backend, if we're talking about IoT. It could be the code that we write in-house, but it also could come from use of unsafe libraries or unsafe development environments. This can be open source or it can be proprietary. If you think about this for a minute, some of the biggest issues that we've had in recent years revolve around things to do with the software development lifecycle. Everyone knows what the bottom one here is? Heartbleed. Open SSL library had a security deficiency in the coding, which became a major problem with lots and lots of e-commerce sites or web applications. What's the one on the right? iOS development. You heard of Xcode Ghost? So remember, the Chinese version of the iOS development library was made available externally to the main app store, but someone had put in malware routines into the code, so thousands of applications written with the pirated version of the development environment got released into app stores because they were trusted. And recently, the Struts 2 issues in a software supply chain. So, one common thing that often comes out is we can sort this with pen testing, can't we? We'll just get a security team in at the end of development and we'll stimulate an attack on the application and we're all done. It's, after all, a component of our overall security assessment. I would tell, though, that we're approaching this problem completely wrong, and we have been for years. If you're only doing an end of cycle or an annual pen test, this just gives minimal security. There's too many variables, there's too little time to actually ensure real security. And I like to compare it, the problem if you like, as an iceberg. You see the little bit sticking out the top. We can do our 2 weeks of external hacking, pen testing, but underneath there is a significant amount of man-years of development. People don't see it. There's flaws in security, in the code, in the integration. There's a whole lot that you don't see. This may be inconvenient, but it's an inconvenient truth. Going back to what I said on my first slide, an attacker's only got to be lucky once. They have 24/7 times 365 to attack. So it can be ongoing and it can be continuous. If we are defending, and we're defending application code, Defender perhaps has 20 man days per year to detect and defend, at selective points to do our pen test. Who has the edge in that case? It's certainly not us as the defenders. The attacker has everything going for them. From another point of view, if you just thought, I can stick a firewall, well, usually most of the application vulnerabilities go straight through firewalls. Even if it's a WAF, a web application firewall, you're only detecting what you know. If you don't know your code very well, then how can you protect it? So, I think there's a gap. There's a wide chasm between security professionals, application developers, and quality professionals. Security professionals that don't know the applications. If you are a traditional network security professional, you probably don't know about your organisation's web applications. How do they work? How can I help protect them if I don't know how they operate? Application developers or testers don't know security. You can build great features, all singing, all dancing GUIs, meet tight deadlines, but I don't know how to develop my application with security built in. There's a gap there that needs to be filled. Another way of looking at it, also known as Weinberg's second law, if builders built buildings the same way programmers wrote programs, the first woodpecker that came along would destroy civilization. Perhaps an overstatement, but you get the point. So, how do we fix the problem? There are several different facets, or different things you have to take into consideration. Take the security professional, the security analyst, if you like. They should be involved in understanding the data and the information held in the application. Until that happens, how do they know how to defend? Understanding the type of users using the application is half the battle. They should be the analyst should be involved in the design phase of the application. What about from the developer's point of view? Developers should be embracing secure application development, baking security in the frameworks when they can, thinking about quality. Quality is not just about does it work, does it meet the requirements. Security should also be a measure of quality as well. From the testing QA point of view, security vulnerabilities should be considered as bugs, the same way as a functional bug and tracked in the same manner for revisions to code. What about management? What about boardroom? Time needs to be built into the project plan for security. Security is added value for the application. The little bit of money you spend now saves a 10-fold increase during development or a 100-fold increase saving after release. So we can look at this from a top-down and a bottom-up approach. Developers don't always have the time to test adequately, if at all. Developers don't know secure coding practices. A lot of developers are under pressure to be the first to market. Our product needs to be out there, it needs to be first, it needs to be seen, it's the one people are going to remember. Oh, security, we can deal with that later. In that pressure to be the first to market, there's the sort of COTS approach, customised off-the-shelf components or library use. Nobody writes all their own code anymore, do they? Saving time and money, that's still an issue. So how do we solve that sort of from a bottom-up point of view? Education. Developers taught secure coding techniques. Is this developers, the new ones coming along? Is this the existing teams? We'll come on to this. From a testing point of view, not just functionality or user experience testing, but security built in from the first principles. Sanitize third-party products and libraries. Think about your testing throughout the software development lifecycle. Think about it from a white box, not just a last-minute black box pen testing approach. If that's all you're doing, then you've already built in the problems. But I think we should be looking at it from a top-down approach as well. The issues are, from board level down, there's a pressure to be first to market, focusing on product features, user experience, and not security. Sometimes security doesn't even get mentioned in the boardroom. If your pure focus is cost reduction, ignoring the security risk, then you're going to have security issues pop out post-production. And that is going to cost you more in the long run. For a lot of organisations, there's a lack of a security culture. It's not seen as a boardroom priority, or it only becomes a boardroom priority when you've had the data breach. What I would preach is that it needs to be a boardroom priority now before you have the breach. Again, education. Boardroom, senior management need to see security as a necessity to build in from the start. It's also about representation. Maybe there should be a CISO on the board. Someone to drive through a security culture in the organisation. If you adopt a top-down and bottom-up approach, then you're going to have some sort of equilibrium. So you're going to build in security in developing your products, and you're going to have a security culture that is supported from the boardroom down. And you're going to meet in the middle. So it's not bash the boardroom, bash the developer. It's an education approach to both. So when I said the need for education, I wasn't joking. It's about educating each of the sectors. Yet we've talked about educating users, security awareness program, but security is everyone's responsibility. We need to educate our developers, the developers of tomorrow, and the developers of today as well. For the next generation, we embed secure coding into the computer science curriculum. Now we're starting to make a start. The computing professors and heads of computing panel, along with the BCS and ISC Squared, have their Communities of Practice initiative, embedding computing, secure coding into the computer science curriculum. That's talking about not just, I've got a security module, I'll bolt it onto my computing program, but ensuring that when students start their first year, they do their first introduction to programming module, there is secure programming embedded within that first module and throughout the computer science program. So when you learn about databases, there's secure program for databases included, network security, the ethics of the security industry, penetration testing, all part of the program, but embedded within the computer science curriculum. OWASP are working on an application security framework curriculum. Well, that's me. And there's the new IISP CREST academic framework that's being released. And this is all of these are embedded within these types of program. And there's even some of the new apprenticeships, I think the next speaker is talking about, that these sort of idea of secure coding will be embedded within those new apprenticeships. So we're starting to think about getting it right for the next generation. But what do we do about the existing generation? Universities, colleges have churned out a lot of developers in the time that perhaps aren't aware of the need for input validation, all those wonderful things. Then organisations should adopt secure coding programs and workshops and revision follow-ups. Don't do it once, because you recruit new developers. Developers move jobs. Some change roles, some get promoted, some get demoted. All I'd say, a dog is not just for Christmas. What I mean by that is, you start a program, you keep with it, you keep refreshing, you keep updating. The development environment may change for your product sets. If that does, you probably need to adjust your secure coding program. From the QA, from the testing point of view, ensure that the testers are educated about testing throughout the software development lifecycle, not just at the end. Adopt other people's good practice. I'll wave the OWASP flag, the OWASP testing guide. Education is for the board as well, and for senior management. They need to be educated to build security in from the start as a business benefit. Not just, we've got to do something about a breach, we can't suffer one of them. Security is part of a culture, and the board should take the lead in developing that security culture. If we're building it into our developers from the bottom up, they get promoted, so the secure coding practices and security culture grows from there, but you can push it down as well. In fact, security is everyone's responsibility. So who can help? Well, I'll wave the OWASP flag, because that's who I do a lot of my outreach work with. Everyone heard of the OWASP Top 10? Anyone using the OWASP Top 10? So the top 10 vulnerabilities in web application development. Anyone tell me what number one in the top 10 has been consistently?
Input validation?
That's a solution. What's the problem? So what's the problem? Not cross-site scripting?
Unsanitizing insecure web interfaces.
No, number one is injection attacks. SQL injection. Top way to stop SQL injection? Input validation. Or one way. Sanitizing your inputs. It's been there. This is something we've known about for 20 years, but it still happens now. And it's one of the biggest ways that hackers can retrieve information from back-end databases. So if you hadn't heard of OWASP, the Open Web Application Security Project, not-for-profit organisation that is worldwide, 250 plus chapters, about 10 in the UK. I run the one in Cambridge. There are representatives here. I think Sam's here from the London chapter. Chapters in Bristol, Manchester, Birmingham, Scotland, Northern Ireland, Bristol, amongst a few others. So there's a chapter near you. OWASP mission is to help organisations develop, purchase and maintain software applications that can be trusted. It's about educating developers, designers, architects, business owners about the risks associated with the most common web application security vulnerabilities. As I said before, the most well-known product is the popular top 10. And there's top 10s not just for web app vulnerabilities, but for mobile applications, IoT, all kinds of areas. What OWASP tends to do is support and sponsor the development of tools, documents, and code library projects. Everything OWASP does is free at the point of delivery. They're released under Creative Commons licenses, so you can build them into your own programs, you can redevelop the tools, you can use any of the documentation. It's just as long as you acknowledge the source. One really useful document I found, and again it's a bit difficult to read because it's small up there, is the Quick Developer's Guide. The Quick Developer's Guide is a roadmap of, well, where do I go for information? Here's some pointers if you're new to application security, where should you start? And that can be cheat guides, it can be YouTube videos, the top 10. If you want to see vulnerabilities, learn how they happen. If you want to practice hacking your web app and testing for vulnerabilities, what tools are there I can use? One of OWASP's major tools that we released is the Z attack proxy, which was developed by one of the lead developers in Mozilla, who worked on it, a guy called Simon Bennett, who worked on it as a job for Mozilla. If you use Zap, if you think about any sort of proxy you might use, Burp Suite, it's a complementary product alongside Burp Suite. There are checklists you can use. Things to help you with how you secure your site. How can I check for vulnerable libraries in my web application? There are developers' guides and tools to help you analyse your code better. Anyone wants more details, I'm happy to send this to you or give you a URL where you can download it for yourself. Now, I'm just going to round up with one set of thoughts. So, if the application is where the problems are, how could things get possibly worse? So, rather than just thinking about a single application, if we think about a hot technology that perhaps exemplifies the problem we have, the Internet of Things, the Internet of Trouble, or the Internet of terrific things, there are so many problems, half the battle is knowing where to begin. What I like to say is IoT security is not device security. There are too many facets, there are too many surfaces, there are too many issues with IoT just to be about device security. Stealing a page from one of my colleagues in OWASP, who quickly penned a list of what he thought was the IoT attack surfaces. Lots of different interfaces, lots of APIs, some network bits, some memory. The one thing that screams at me is lots and lots of applications. And I think the Internet of Things is one very large multi-application problem. And we're pushed adding more and more applications. There is no security per se for the Internet of Things as yet. There is no standard. The best approach at the moment is to secure as much of the application as you can. Questions?
Do you think the world of DevOps requires a different security model, or is it more of the same? So,
I mean, there is a spin-off of DevOps, which is secure DevOps, which, if you're going through the cycle, I guess, of continuous improvement, then as long as you're security aware into that process, then and you're building the same sort of safeguards in, as long as you're building it in from the start, then I don't see any issues. As long as it's thought through, I don't have any issues now.
Have you done any work on the statistics to put this into proportion? There was an article in The Economist magazine just the last couple of weeks, which was quoting the number of errors occurring in code, for example. Whatever the percentages are, they can be improved, but even the best leave something like 0.5% of code lines have errors in them. Now, not all of those code errors are exploitable, even in all of the apps that we've got. So what we're missing in the discussion of this is actually what's the risk balance, and how do you deal with that? So we can do fear, uncertainty, and doubt in all of this, but now give us some evidence about the risk balance, please.
Okay, so I'll take your point. There are always going to be errors in code. I think the part of the problem is that some of those errors are perpetuated when we have common libraries, and because we don't write a lot of our own code anymore, we like to take the easy route, but the cheaper route is someone's developed a common set of libraries that do the functions we want. We tend to employ them and pull them into our code. But if those libraries have not been sanitized or properly risk assessed, then we just embed more problems. But I do take your point. There will still be lots of errors in code that we won't find with the best testing regime in the world. But what I'm advocating is that we should be thinking about security in our software development life cycle. And we should be security should be a facet at each testing point as well.
how do you make that testing proportionate? That's the point. In terms
Yeah.
of there's a cost.
There's a cost, but the bigger cost is not doing it.
Potentially.
Yeah, all right. Devil's advocate, yes, there is more work to do.
Yeah, just to kind of answer some of what that guy, the question he's asking there. Carnegie Mellon University did a study about 5 or 6 or 7 years ago now, and they found that 1 in every, I think it was 200 lines of code had some sort of vulnerability in it. Different levels of vulnerability. But if you think how many lines of code in Windows 7, I'm guessing 10, 20 million lines. I don't know if that answers your question, but it might give you some idea of the, from an academic point of view, what some of the studies are saying. A little bit old, I grant you, but probably hasn't changed that much.
That evidence has been around for some time. It still doesn't tell you how many of those are exploitable or what the outcomes are if they are exploitable. So actually, if you're managing a risk in terms of investment, you still don't have any good evidence to decide on what to do. The industry is not in a good position in actually making decisions, effective decisions on how much of this to do.
You mentioned before about coders going to libraries to effectively grab hold of code that's already been written to produce the same output. I was wondering what sort of testing is done on those libraries, so to make sure that people are grabbing secure code rather than just reusing cracked code.
There are some, Maven Central, who hold some code libraries. I think it's a will offer some sanitization, but it doesn't. It de-risks some of it. It doesn't completely de-risk. No. But I think you're looking for, because you can't, as an individual developer or an individual organisation, you cannot sanitize every single library. You have to take something on trust. But who do you trust? Is part of the question.
Can I actually add to Adrian's answer here? So I'm also from OWASP, but OWASP London. So OWASP actually does have a free tool, which is called Dependency Checker, which you can integrate using DevOps into your development lifecycle. It will automatically check that any libraries that the developers use are free of known vulnerabilities. So talk about known vulnerabilities. The same thing, for example, ZAP that Adrian talked about, which is obviously a pen testing tool. You can also now automate and integrate it to DevOps. So as soon as developers push a new version of the code, it can be tested straight away. So the toolkit is there, and there are free tools available.